Hello, myself Ramesh, Assistant Professor in Physics in Mlritm. So today we are going to discuss about photoelectric effect experiments. So this is one of the experiment in Applied Physics lab for first year BTech. So let's go to our topic. So photoelectric effect. So photoelectric effect is nothing but the phenomena of emission of electrons from metal surface when light incidented on it. Okay, so the phenomena of emission of electrons from the surface of material when light falls on it, that phenomena we can call as photoelectric effect here. So which means, as I shown here in this figure, so here this is the metal surface, for example. So on this metal surface, so the photons are incidenting like this. So as a result, these incidented photons strikes the metallic atoms, and from the metallic atoms free electrons are get ejected. So photoelectric effect is nothing but, as I told you, emission of electrons from metal surface when suitable light incidented on it. So here on this in this figure you can see, so the metal surface consisting of metallic atoms. On this metallic atoms when the photons are incidenting, so as a result the free electrons are get ejected from the metallic atoms here. So these ejected electrons causes for current generation in photoelectric effect here. So this generated current we can call as photocurrent here. So this is the basic phenomena working behind this photoelectric effect experiment here. So here in this experiment, what we are going to determine, the purpose why we are doing this experiment in the sense, by performing this photoelectric effect experiment, so we are going to determine the parameter called work function. Okay, work function psi we are going to determine by using photoelectric effect here. Okay, so we will see what is work function and how can we calculate this work function for a given metal surface. All these things we will see. And here this is the circuit diagram we are using to connect the equipment to execute this photoelectric effect experiment here. So here in this circuit diagram you can see that here this is the photocell. Okay, so this is the photocell device. On this photocell device we are incidenting the light. So a suitable wavelength we are incidenting on this photocell. As a result, current produces in this photocell here. So this generated current you can see in this microammeter. So a microammeter also we are connecting in this circuit. Here in this microammeter you can check how much current is generated by incidenting a certain intensity of light on it. And also here you are also having a voltmeter connected to in this circuit diagram. So by using this voltmeter, we are going to supply voltage to the photocell here. So by application of voltage to the photocell, how the generated current changes. Okay, so we can say that by increasing the potential to the photocell while incidenting the light. So if you keep on increasing the voltage supply to the photocell, you can observe that the ejection of electrons from metal surface slowly decreases, which means the current generation slowly decreases, and at a certain voltage the generated current can comes to zero, right? So this particular voltage what we are applying to bring the generated current to zero. So that voltage we can call as stopping potential or stopping voltage here, right? And also here this is the power supply we are providing to the photocell. So these are the components we are connecting to execute this photoelectric experiment here. Here you can see the operators what we are using in this experiment. So photocell, metal surface, digital milliammeter, digital voltmeter, and different wavelengths of LEDs. So different wavelengths, nothing but different colors of LEDs we are using. So in the place of different colors, we can use color filters. Okay, we can use one light source which is emitting white light. So according to the white light, we can also use color filters. So the purpose of using color filters is to get a certain wavelength. Instead of using different wavelength LEDs, we can take white LED or white light source, and in front of white light source, if you place these different types of color filters. So for example, red color filter if I am placing before light source. So that color filter filters the remaining wavelengths and allows only red wavelength. to pass through it. So that red wavelength we can incident on photocell, and by incidenting that red wavelength, how much current produces in the milliammeter we can check. So similarly, by placing different color filters, we can incident different wavelengths on photocell, and we can observe for each wavelength how much current is producing in the photocell. So all those things we can observe in the experiment while we are executing. So, and the next thing here, this is the formula we are using to find out the work function. Okay, work function psi is equals to hf minus ev naught. So here, what is work function first? So work function is nothing but the minimum amount of energy required to eject an electron from metal surface. So when you incident photons on metal surface, we know that as per the photoelectric effect, electrons are getting ejected from the metal surface. So how much energy is required to eject an electron from metal surface? That minimum amount of energy we can call as work function here. So to find out this work function in this experiment, we are using this formula hf minus ev naught. So in this, h is nothing but Planck's constant and f is nothing but the frequency what we are incidenting on metal surface, and small e is representing the charge of electron, the constant value, and v naught is representing the stopping potential value. Okay, what is the stopping potential by incidenting that particular wavelength or frequency on that metal surface? So these are the components we are substituting in this formula to calculate this work function psi here. So this is about the formula what we are using to find out work function here. And next, let us see how the process takes place according to photoelectric effect. We can see here in this schematic diagram. So here in this schematic diagram, you can see that here this is the vacuum tube. Okay, so here in this vacuum tube, so we are removing all the gas environment and we are creating vacuum inside, and we are placing a emitter and collector setup at both ends here. So the emitter is nothing but our metal surface. Okay, the matter or material what we are using to execute photoelectric effect. So that is nothing but emitter we can take. Next, collector. So collector which collects the ejected electrons from metal surface, here it is. So now whenever we are incidenting some photons, here the red color arrow mark indicates nothing but we are incidenting some light energy on this metal surface here. As a result, as per the phenomena, so free electrons are getting ejected from the metal surface here. So these red color arrow marks are indicating the ejected free electrons from the metal surface here. So these ejected free electrons are attracted by the collector setup. So this collector is collecting the ejected free electrons, and here it shows the amount of current, how much current is produced by incidenting a certain wavelength on metal surface. You can check in the milliammeter here, so which is connected in the same circuit diagram. So in the milliammeter, you can see how much current is producing by incidenting a certain wavelength on the metal surface here. So like this, the photoelectric effect experiment we can execute as shown in this circuit diagram here. So here also you can see the photoelectric effect is a phenomena in which electrons are emitted from matter. So matter is nothing but our metal surface what we are taking. So matter in the sense you can take either metal, gas, solid, whatever it is. So metals and non-metals, solids, liquids, gases all comes under matter as we know. So next, whenever light of suitable wavelength or frequency falls on that particular surface. Okay, suitable wavelength you need to incident. If you incident any type of wavelength, you can't get the photoelectrons here. A suitable or frequency or wavelength, whenever you incident, then only you can observe the ejection of electrons from the metal surface here. Right? So this is about the schematic representation of photoelectric effect, we can say. So next to this, here, this is the experimental setup what we are using in the laboratory to execute photoelectric effect experiment here. So in this experimental setup, you can see here this is the light source we are using. Okay, so as per the definition, we need to incident light on metal surface. So the light, to emit the light energy, we are using this light source here. So this light source emits white light. Okay, while we are executing the experiment, so when you switch on the light, so white light can be emitted from this light source here. And next, here this is the metal surface we are using. Okay, so inside we are having a photo cell arrangement, a metal surface it consisting of. So we are placing this metal surface in front of light source. Okay, so 1 and 2. So 1 is nothing but our light source and 2 is nothing but our metal surface. So when you place this metal surface in front of light source, when you switch on the light, automatically the light energy falls on the metal surface, and here these are the connecting, okay, so connection contacts. So this metal surface, so this photocell device we are connecting to this setup. So this is setup 3. So this is setup 3 consisting of a voltmeter and ammeter setup. Okay, so voltmeter we are using to apply some voltage to the photocell, and ammeter, so digital ammeter. In this digital ammeter you can see when you incident light on photocell, how much current is producing in the photocell, you can see in the milliammeter here, right? So for that purpose we are having this arrangement here. And next, here this is the fourth operator what we are using in the experiment is, so these are the different color filters. Okay, so different color filters we are using to incident different wavelengths on photocell. We are using these color filters here. So here in front of, here you are placing the color filters in front of photocell. Okay, so in front of metallic surface we are having a slot setup. So in this slot we are placing these transparent filters here in front of the metal surface here. So when light falls on these filters, so these filters are filtering remaining wavelengths and they are allowing a particular wavelength to incident on metal surface. So this photocell connected to this experimental setup 3. So here that is the reason whenever we are incidenting a particular wavelength on metal surface, automatically, so how much current is producing in the metal surface you can see here in the ammeter here. So here in this ammeter you can see the reading, how much current is producing for that wavelength, right? And next, after observing a certain amount of current by incidenting a wavelength on metal surface, what next we are going to do in the experiment in the sense, next, here as I told you this is the voltmeter. So this is the voltmeter setup. So by using this knob, so we are increasing the voltage at that point. So when you keep on increasing the voltage, you can see here in this milliammeter, whatever the current we observed, so that current slowly decreases. Okay, so why it is decreasing in the sense, while you are applying some potential to the metal surface, the ejection of electrons slowly decreases from metal surface, which causes decrease in current in the milliammeter here. When you keep on increasing the voltage, so at certain voltage you can find that the reading in the milliammeter, nothing but current, becomes 0. Okay, so which means, so the ejection of electrons are decreased to 0 from the metal surface here. So that particular voltage what we applied to bring the current to 0 is called as stopping potential here. So stopping potential, which we indicates with V naught, right? So that is the way we are executing the experiment here. And next to that, so for example, previously we used the red color filter. By incidenting red wavelength, we measured the stopping potential here. And next, after red color filter, the same process we need to execute for different color filters. So we are having blue color filter, green color filter, orange color filter, like different color filters we are having. So red filter we are incidented in the sense, red light we are incidented on photocell and we are calculated the stopping potential for red wavelength. Similarly, if you place the green color filter in front of photocell and if you incident the green wavelength on photocell, same you can observe some current for green wavelength. So by increasing voltage, we need to bring that generated current to 0, and by that we can find out the stopping potential for green wavelength also. The same process we can do for different color filters, means different wavelengths. We can incident on photocell and we can find out the stopping potential for different wavelengths here. So by that we can calculate the stopping point, this work function here. So here this is the tabular column which we are using to calculate the work function value. So as I shown, the first column is representing yellow color, green color, blue color, violet and ultraviolet. So these are the different wavelengths we are incidenting on metal surface here. So which means, for example, the first color is yellow. So yellow filter we are placing in front of photocell and we are incidenting white light on that. So the yellow filter allows only yellow wavelength to incident on metal surface, and in milliammeter you can check the how much current is generated by incidenting yellow wavelength on metal surface here. So and next we are applying the voltage at that instant. By increasing voltage at that instant, the generated current slowly decreases and particularly it comes to zero at a particular voltage. So that voltage is nothing but stopping voltage for yellow wavelength here. Okay, so whatever the voltage value you will get while executing the experiment, that value you need to substitute here in this column. Okay, so opposite to yellow color. And also you are having two more columns here, frequency and wavelength. Okay, so yellow color standard wavelength we can write in the place of wavelength, and frequency. So frequency f is equals to, the formula is c by lambda. So by using the formula f is equals to c by lambda, you can calculate the frequency of yellow and you can substitute here, where c is the light velocity and lambda is the standard value of yellow wavelength. So by substituting you can get the frequency also. And this stopping potential of yellow you will get by executing the experiment. And finally coming to our final calculation, work function. So work function psi is equals to hf minus ev naught. So in this formula, where h is nothing but Planck's constant. So the Planck's constant value you can substitute there. And the next f is nothing but frequency. So which colors work function we are calculating now? We are calculating yellow color work function. So that's why, so yellow color frequency, whatever you are calculated by c by lambda formula. So that f value you need to substitute in the work function formula here. And the next E. So where E represents charge of electron. Okay, charge of electron, the fixed value we know 1.6 into 10 power minus 90. So that value you can substitute in the place of E. And finally E, V naught. So V naught is nothing but our stopping potential. So already we got the stopping potential by executing the experiment. So that value you can substitute in the formula. So then you can get the value of work function for yellow wavelength here. So similarly, in the same process, by changing the filters in the experiment, you can calculate the work function for green color, blue color, violet color and ultraviolet color also. So this is the way we can calculate the work function for given different wavelengths by using photoelectric experiment here. And the next here, this is the graph. So by using the graph also you can calculate the work function here. So here in this graph, on x-axis you are taking frequency. Okay, so whatever the frequencies we are using in the experiment, so these frequency values in increasing order you can take on x-axis here. And on y-axis, so and on y-axis we are using stopping potential V naught. Okay, stopping potential V naught values we are taking on y-axis. So then the consecutive values whatever we got in the tabular column. So for these values, frequency versus stopping potential, by keeping the points whatever you got, you can draw a line. So if you draw the line is touching the y-axis at negative n. Okay, so at negative n, so whatever the value you got, so this value is nothing but our work function for given metal surface. Okay, the work function of metal surface you can calculate by using graphical representation also in this manner. Okay, so the negative side, whatever the value you got, so the line where it is touching, so that value you can call as work function here. And next this value, So this frequency where this line is touching the line, so this frequency you can call as threshold frequency. So what is meant by threshold frequency in the sense? So when you are incidenting the different wavelengths or frequencies on the metal surface, the ejection of electrons starts from a particular frequency only. When you keep on increasing the different frequencies incident on the metal surface, so for a particular frequency only you can observe the ejection of electrons from metal surface, right? So that particular frequency from where the ejection of electrons are taking place is called threshold frequency here. So that threshold frequency value also you can find out from the graph here. So this is the way you can calculate work function and threshold frequency of given photocell device by conducting this experiment here. And also in the previous slides we are having a step-by-step procedure. So how can we connect and how can we execute the experiment? You can get the information from these points here. So here these are the operators, as I told you, 1, 2, 3. So operator and 4. So operator 1 is nothing but light source, operator 2 is nothing but our photocell metal surface, and operator 3 is nothing but volt milliammeter and millivoltmeter setups, and operator 4 is nothing but our color filters. And we should also use some connecting wires to connect all these components. So now let us see. So the procedure step by step, let's see briefly. So the Planck's constant setup and fix the photo vacuum tube at particular position. Okay, so here we are not using any vacuum tube. So directly photocell arrangement we are using here. So next, complete the circuit connections as shown in the diagram. So previously we saw the circuit diagram. So with the help of the circuit diagram, we need to connect all the components by using connecting wires here. Next, connect the main cords, switch on the power supply and light source. Now you can observe some value of current on ammeter. So let us place the photocell in front of light source and insert a filter in front of the photocell and switch on the light. The light incidents on photocell and as a result some amount of current can be the generated current you can see in the milliammeter in the experiment here. Next, first insert the red color filter in front of the photocell. So okay, next observe the current is too low, then set photo vacuum tube towards light source, still get some appreciable current. Fix the photo tube at this distance, position 1. So nothing but, so adjust the photocell in front of light source at a particular distance to observe some usable amount of current. Next, now vary the DC voltage slowly, variable resistance, see the values of current. It should decrease as shown as we are increasing the voltage. So the same. So when you observe some amount of current in milliammeter, the next step you need to increase the voltage. While you are increasing the voltage, we can observe that slowly the current values are decreasing. Okay, and at a certain DC voltage, you can observe that the current is completely becomes to 0. So that particular voltage what we applied to bring the current to 0 is called stopping potential V0 here, and repeat it for 7 to 10 filters. Means different color filters let us use, and let us calculate the stopping potential values for different wavelengths. Okay, after calculation, so like this. So after placing the color filters, we can find out the stopping potential values. Okay, different stopping potential values you can get. So for yellow color, for green color, blue color, violet, ultraviolet. So for different colors, you can get the stopping potential values and frequency and wavelength. These values also, the standard wavelength values you can mention here. With the help of the C by lambda formula, you can find out the frequency of each and every color also you can write here by calculating. And finally, with the help of all these values, frequency, this Planck's constant, charge of electron and stopping potential, you can calculate the work function for different colors in this manner, right? So this is the way we can execute the photoelectric experiment in our lab here. Thank you for listening. Thank you.